This lecture is on foundation of learning. Machine learning is an application of artificial intelligence that provides system the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it to learn for themselves. Machine learning is a powerful tool that drives everything from curated content recommendation to optimized user interface. Machine learning answers questions about user behavior. Machine learning customizes interfaces to users' needs. Learning versus designing. Design and machine learning function like a flywheel. When connected, each provide value to the other. Together, they open up new product experience and business value. Designs help machine learning gather better data. Machine learning is a hungry animal. To deliver the best results, learning algorithms need vast amount of detailed data, clean of any confounding factors or built-in biases. Designers can help create user experience that eliminate noise in data, leading to more accurate and efficient ML-powered applications. Design helps set expectation and establish trust with the user. Here comes the types of learning. Machine learning can be classified into three types of algorithm. Supervised learning is another machine learning method in which patterns inferred from the labeled input data. Unsupervised learning is another machine learning method in which patterns are inferred from the unlabeled input data. Reinforcement learning is employed by various software and machines to find the best possible behavior or path it should take in a specific situation. What is supervised learning in detail? In supervised learning, the computer is taught by example. It learns from past data and applies the learning to present data to predict future events. In this case, both input and desired output data provide help to prediction of future events. Supervised machine learning categorization. It is important to remember that all supervised learning algorithms are essentially complex algorithms categorized as either classification or regression models. Classification models. Classification models are used for problems where the output variable can be categorized such as yes or no and pass or fail. Classification models are used to predict the category of the data. Real-time life example includes spam detection, sentiment analysis, scorecard prediction of exams, etc. Regression models. Regression models are used for problems where the output variable is a real value such as unique number, dollar, salary, weight, or pressure. For example, it is most often used to predict numerical values based on previous data observation. Some of the familiar regression algorithms include linear regression, logistic regression, polynomial regression, and ridge regression. Supervised machine learning categorization. These are some very practically applications of supervised learning algorithms in real life, including text categorization, face detection, signature recognition, customer discovery, spam detection, weather forecasting, predicting house prices based on the prevailing market price, stock price prediction, among others. Unsupervised learning. Unsupervised learning is a machine learning technique where you do not need to supervise the model. Instead, you need to allow the model to work on its own to discover information. It mainly deals with the unlabeled data. Unsupervised learning problems are further classified into clustering and association problems. Clustering is one of the most commonly used unsupervised learning technique. This method of clustering involves organizing unlabeled data into similar groups called clusters. Thus, a cluster is a collection of similar data items. The primary goal here is to find similarities in the data points and group similar data points into a cluster. Association. Association rules allows to establish association among data objects inside large databases. The unsupervised technique is about discovering exciting relationship between variables in large databases. For example, people that buy a new house are most likely to buy new furniture. An association rule has two parts, an antecedent if and a consequent then. If a customer buys bread, he is 70% likely of buying milk. In the above association rule, bread is an antecedent and milk is a consequence. Here comes the difference between supervised learning versus unsupervised learning. There are parameters such as process, input data, algorithm used, use of data, accuracy of result, number of classes, and main drawbacks. Supervised machine learning techniques. Input and output variable will be given, whereas in unsupervised machine learning techniques, only input data will be given. Here, algorithms are trained using labeled data, whereas in unsupervised machine learning techniques, algorithms are used against data which is not labeled. The algorithm used in supervised machine learning techniques are support vector machine, neural network, linear and logistic regression, random forest, and classification of trees. In unsupervised algorithms, it can be divided into different categories like cluster algorithms, k-means, hierarchical clustering, etc. The use of data in supervised machine learning techniques is to learn and link between the input and the outputs. In unsupervised learning, it does not use the output data. The accuracy of result is highly accurate in a supervised machine learning technique, whereas it is less accurate and trustworthy method in unsupervised machine learning technique. The number of classes in supervised machine learning technique is known, whereas in unsupervised machine learning technique, the number of classes is not known. The main drawback of supervised machine learning technique is classifying big data can be a real challenge. Whereas in unsupervised machine learning technique, you cannot use precise information regarding data sorting and the output as data used in unsupervised learning is labeled and not known. Reinforcement learning. Reinforcement learning is a type of learning that is based on the interaction with the environment. However, there might be different paths for reaching the end state like a maze. Example for reinforcement learning include self-navigating vacuum cleaners, driverless cars, scheduling of elevators, etc. The picture given below can help us understand reinforcement learning in a better way. Here comes the end of the lecture. Thanks for watching.